Assalamualaikum and good evening to my FRP coordinator, panel and all the audience. My name is Ahmad Firdaus bin Azhar. So without wasting time, I will start my FIP presentation. My project title is Analysis of Liquefied Petroleum Gas (LPG) Sensing with Different Model of Sensor. Now we proceed to the problem statement. There have been quite a few reported cases in our country regarding LPG leakage and explosions, where most of them are catastrophic and involve fatality. The LPG gas sensor is a very appropriate effort in dealing with early detection of LPG leakage to minimize the occurrence. However, there are limited studies and research involving different models of readily available LPG gas sensor on the market other than MQ6 gas sensor. Therefore, this research aimed to conduct a performance analysis of the other two models of LPG sensor, which are the MQ9 and MICS 5524 gas sensor, along with MQ6 gas sensor itself. There are three objectives for this research. The first one, to study the sensing behavior of MQ6, the MQ9, and MICS 5524 gas sensor. Second one, to measure the performance of each of the sensor towards LPG gas in terms of sensitivity, selectivity, sensing distance, size, variation, and resistance adjustment by conducting few types of experiment. The final objective is to determine which sensor is the best to be used depending on situation. Now we move to methodology. This is the general flowchart of the study where the coding process and each experiment will be explained one by one in the coming slide. Okay, as for the coding, firstly determine 2 points from the technical graph of the sensor, then insert the value into the formula given. Obtain the relationship between Rs over Ro, where Rs refer to the resistance of the sensor that changes depending on the concentration of gas, and Ro refer to resistance of the sensor at known concentration without presence of other gases. Once Ro value had been determined, insert the value into coding provided. Experiment 1 is about sensitivity test of the sensor. An airtight chamber size of 2 liter will be used throughout this experiment. LPG concentration will be set at 50 and 100 ml. The experiment begins by placing the sensor module inside the chamber. Then LPG gas will be injected through the small hole before the mini fan turn on to make sure the gas circulate evenly inside the chamber. All measurement will be taken after 10 seconds of injecting gas into the chamber to give some time for the LPG gas to spread around the chamber. The reading for concentration will be taken after 10 seconds. Each of the tests will be performed for 5 times to get average reading. Experiment 2 is about selectivity test of the sensor. An airtight chamber of 2 liter will be used throughout the experiment. LPG concentration will be set at 100 ml. The experiment begins by placing the sensor module inside the chamber. This testing will be divided into two situations. First, without the presence of the smoke, and second, with the presence of the smoke. Experiment 3 is about sensor response to the size of the chamber used to observe the changes in concentration detection. An airtight chamber of 2, 9, and 22 liter will be used throughout the experiment. LPG concentration will be set at 100 ml. Experiment 4 is about sensor response toward the distance variation of LPG sensor to the LPG source with different value of resistance. The distance that will be used in this experiment is 5 and 10 cm, while the resistance value is set at 5 kilo and 10 kilo ohm. Basically, the experiment is to show that how resistance value adjustment will improve the sensor sensitivity at certain distance. Once the distance and resistance value have been set, the LPG will be injected using consistent pressure throughout the experiment. Now we move to result and discussion. For experiment 1, it shows that MQ6 gas sensor sensitivity towards higher and lower concentration have a very huge difference. Seems like MQ6 performance will drastically drop when lower concentration is used. As for the MQ9, it shows that the MQ9 perform lesser in higher concentration compared to MQ6 and MICS 5524, but it performed much better than MQ6 in lower concentration. It also gives a very stable reading throughout the test compared to the other two sensors. Finally, for MICS 5524, it shows a very unstable reading at higher concentration, although the reading shows it have the best sensitivity among the three gas sensors, both in high and low concentration. For experiment 2, it shows that MQC gas sensor have a very good selectivity where only a small number of reading drop compared to the real reading after the smoke was introduced. For the MQ9 and MICS 5524, since both of the sensors have the capability to detect other substance and gases including smoke but doesn't have the capability to specify the substance it detects, both of the sensors are having higher reading after the smoke was introduced. However, they have different behavior of displaying the end reading. For example, the MQ9 end reading shows the concentration of smoke and LPG seems to add up. But for MICS 5524, the reading will skyrocket when there is two substances in its detection list presence. This have been proved by testing the sensor with other substance which is alcohol. It seems that for this experiment, MQ6 dominated the result by being the least if affected sensor with the presence of other substance. Experiment 3 It shows that MQ6 gas sensor behaves similarly in experiment 1, where this time the reading will drastically drop when bigger space is used. Same goes to the pattern of the MQ9 in this experiment, where MQ6 will outperform it on the smaller space, but the opposite happened in bigger space, while MICS 5524 still giving unstable reading at smaller space, where the intensity of the LPG concentration is the highest. But still, it gives the best overall result among the three gas sensors. For experiment 4, it shows that increase in distance really affecting MQ6 gas sensor. Looking at the reading at 5 cm distance, which have around 3.1 k ppm average reading, drastically dropped to below 100 ppm for another 5 cm distance addition. For the MQ9, it also shows drastic decrease in detection as the sensor distance from LPG source become further. But still, the reading shows it's performed better than MQ6 in further distance. Finally, MICS 5524 still dominating this experiment as it shows the most sensitive reading in every test. To conclude this study for MQ6, the gas sensor shows excellent performance in selectivity where the reading can be said almost not affected by the smoke. In conclusion, MQ6 gas sensor seems to be the best choice to be placed near the LPG source in household environment, since residential area usually have the high possibility to expose to smoke from burning waste. The cons of the sensor is that it have to be placed very close to the LPG source so that the performance will stay in check, and maybe in some situation or setting will not allow the sensor to do so. For the MQ9, the sensor seems to be a higher end choice for a household since it gives better performance in lower concentrations since it costs a few times more than MQ6. It also can suit certain types of industrial premises because of its ability to detect carbon monoxide and methane gas. The disadvantage of the sensor is that it cannot be set to determine what kind of gas it needs to be detected. So the sensor has the possibility to trigger the alarm although it is not coming from the gas or substance that we concern of. For MICS 5524, the sensor seems to show a big failure in selectivity tests. Although the sensor really suits for industrial purpose since the substance and gases it can detect consist of ammonia, carbon dioxide, alcohol, and LPG, still it also unable to detect all the gases separately, which means whenever one of the gases in that it can detect is in presence of the sensor will sense it just like the MQ9. So the user has to make sure that the environment only have the possibility to expose to the target gases. So that's all from me. Thank you.